Iron and oxygen react to form iron 3 oxide. How much iron 3 oxide can form with 2 moles of iron and 6 moles of oxygen? And which of these is the limiting reactant? So first off, let's start with what we know. First off, we know that we are starting with, for this problem, 2 moles of iron and 6 moles of oxygen. So we've got to do two problems here, and we're going to use the molar ratios that we get in our chemical equation here to figure that out. So we're going to start, first off, I'm going to start with 2 moles of iron. And then I'm going to use the molar ratio of iron to the iron 3 oxide. Notice here we've got 4 iron atoms react with 3 oxygen atoms to form 2 formula units of iron 3 oxide. So our ratio between iron and iron 3 oxide is 4 to 2. Now we could actually reduce that further by just reducing everything by 2. So for this one, we can simply say that for every 2 moles of iron, 1 mole of iron 2 oxide or iron 3 oxide is formed. We don't have to worry about oxygen right now because right now we're looking at the ratio between iron and iron oxide. So quite simply, when we multiply and divide everything across, we find out that 2 moles of iron can give us 1 mole of iron 3 oxide. Now, keep in mind, we can cancel out everything. Our moles of, that's supposed to be a iron there, 2 moles of iron, and we end up with the units that we're looking for. Now let's do the same thing, but for our oxygen. Now, so let's start with what we know. We're starting with 6 moles of oxygen, and now we're going to use the molar ratio between oxygen and iron 3 oxide to figure out how much iron 3 oxide we can get from this amount of oxygen. So for this, since we have a 3 to 2 ratio, I'm going to put my moles of oxygen on the bottom, and there are 3 moles of oxygen for every 2 moles of iron 3 oxide. And I can go through and multiply this fairly quickly. 2 times 6 gives me 12, divided by 3 gives me 4 moles of iron 3 oxide. Now, if I look at both of these numbers here, I've got the smallest amount coming from this amount of iron here. The fact that this is the smallest amount, that means that this particular combination is only going to be able to give us this amount. So in this case, we know that the iron is our limiting reactant. And just so happens here that oxygen is our excess reactant. It's the part that's where a little bit is left over. Okay, now we're going to do something a little bit different. Same problem, same chemical equation, but different amounts of our reactants to start with. This time we are starting with 12 moles of iron and 3 moles of oxygen. So let's figure out which one of these is our limiting reactant and how much iron oxide we're going to be able to get. So first off, let's start with our iron first, since it's listed first. Let's say we got 12 moles of iron out of this mix. And again, we're going to be using our coefficients in our chemical equation to show the molar ratios. And since we've got a 4:2 ratio, we can reduce that to 2:1. So we can make it a little bit easier on ourselves, and we can just say that for every 2 moles of iron, that 1 mole of iron 3 oxide is formed. So now, let me change this really quick. Notice how I'm able to cancel out my moles of iron, and I'm left with the unit that I'm looking for. So that gives me, if I 12 times 1 divided by 2, that gives me 6 moles possible of my iron 3 oxide. So that's one of my reactants here. Now let's take a look at what happens with our oxygen. We've also got 3.0 moles of oxygen in the mix, and our molar ratios, or our coefficients, given to us here, we've got a 3:2 ratio. So in figuring out how many moles of iron oxide, I'm going to use this conversion factor here, and I'm going to put moles of oxygen on the bottom and moles of iron 3 oxide on top. And I've got a 2:3 ratio there. So now I multiply 3 times 2 divided by 3. That gives me simply 2 moles of iron 3 oxide. So just to be consistent here, we can see that the lowest number of, or the lowest amount of iron 3 oxide is coming from the oxygen reactant. So in this case, in this situation, our oxygen is our limiting reactant. So the moral of the story is you can't just tell by looking at the chemical equation and by looking at the amounts of any reactant which one is the limiting reactant. You have to actually go through and do the calculations for both and figure out the smallest amount available, and the one that produces the smallest amount is your limiting reactant.